I've got some silly things here with regard to moles. So remember, 1 mole of anything is equal to what? 6.022 times 10 to the 23rd of those things. And usually it's for very small things because that's a very large number. But let's look at something that's pretty big. Rice grains. You're like, oh my gosh, rice grains are pretty small. Well, they're pretty big compared to atoms. So if you had a mole of rice grains, so that many rice grains, it would cover actually for the planet Earth all of our land area, and it would be 75 meters deep. So although rice are very small, that is a lot of volume. And actually, I would say these problems I'm going to show you or these little statistics could be worked using factor label. Okay, again with the rice grains. So rice grain is a very important staple eaten throughout many cultures on a regular basis. And that a mole of rice grains has not been grown since the beginning of time. So isn't that cool? So it'd be hard to have a mole of rice grains at one place at any time because there's not been that many grown since the beginning of time. So this one says, all right, a mole of rice grains would have a volume actually of a cube, if you're going to put it in a cube, and the dimensions on all sides of the cubes would be 120 miles by 120 miles by 120 miles. And this is your rice grains, 1 mole of rice grains. All right? So, I mean, if you go back to the whole carbon-12 thing, remember we said by definition, if this is my pile of C12 atoms, it weighs what? 12 grams. Very good. So one more thing, or another thing on this slide, a few other things coming up. Switching gears. Now, of course, marshmallows have a larger volume than rice grains, so you're going to have a larger volume of stuff. If you have 1 mole of marshmallows and it was confined to the United States, it would cover the United States 600 miles deep. I always think of the Stay Puft Marshmallow guy in Ghostbusters. Okay, so back to we did this one. Okay, this one, snowflakes. Now, here in Iowa, we've had our fair share of blizzards, but if you have a mole of snowflakes, now snowflakes are pretty small, but you're still talking about a large volume here. And I know snowflakes, some, like if they're very cold, they sometimes are smaller crystals than if they're larger. But in general, if you had a mole of snowflakes, they would cover, again, the United States up to a depth of about 2/3 of a mile. That is crazy. What else we got? Okay. If you were going to say, I'm going to count 1, 2, 3, 4, 5, 6, I'm going to count one object per second, and I'm going to count up to a mole. And I'm going to have everybody on Earth help me do it. Well, it would take, let's see, how does this go? It would take 51,000 times the number of people on Earth at the time this was written, and it would take us 75 years to go ahead and count 1, 2, 3, 4, 5, nonstop. Is that crazy? A mole is a very big number, I'm just saying. Here's one for you. We can talk about how fast a computer is, and at the time this was written, this is pretty fast. I guess it's probably still pretty fast. If you have a computer that can count faster than us, 1,000 millions of instructions per second, and you tell that computer to go into a loop counting Avogadro's number, counting 1 mole up to 6.022 times 10 to the 23rd, this same computer, by the way, this is how fast it was. It can calculate how many people, it can count how many people are in the United States in less than a second. That's how fast it is. But if it was going to count Avogadro's number, it would take 1.9 million years to go through that number of cycles of 1, 2, 3. I just think that is so cool. Well, here's one for you sports fans. If you were to somehow get a mole of hockey pucks, I doubt if there's that many hockey pucks ever been made, but if you could gather them all together, it would be equal in mass to the moon. Again, with the sports fans, if you were to gather basketballs together, the volume, a mole of basketballs, the volume would fit in a ball bag the size of the Earth. That's kind of silly. I think I have one more. Yeah. Now, This one is for those of us who just kind of see a penny and don't pick it up. That's kind of me. Sometimes I will look at the penny and see if it's heads up, and I'll be like, oh, I should pick it up. And I'm like, oh, somebody else might need it. So anyway, so if you had a mole of pennies, I can almost kind of smell the copper and all that pennies. You could go ahead at the time this was written, and you could divide it up, and every person would get their fair share of pennies, which would be awesome. And if you move the decimal place, let's see, at the time this was written and the number of people on Earth, everybody would get 1.5 times 10 to the 14th pennies. You're like, well, that's just pennies. But if you move the decimal place, actually, how many dollars would that be? I'm getting 1.5 times 10 to the 12th dollars. That's a lot of money. I don't know what that would do to the world economy. But, and then everybody could go ahead and start spending $1 million a day, and we would use up our each individual's wealth. It will take just over $4,000 spending at $1 million a day to spend all of our money if we had a mole of pennies divided amongst everybody on Earth. But this goes on to say, and I kind of think of, did you ever watch the show I Dream of Jeannie, where, was it, no, Roger? I think, but Jeannie anyway would grant wishes. And so never wish for a mole of pennies, because a mole of pennies would have quite the volume. It would cover all the land area on Earth up to a depth of 420 meters. So don't ask for a mole of pennies, whatever you do.